Hi everybody, this is the beginning of the last two sections for the class, section 12.4, and it's associated homework number 48. So please have the following in front of you, the notes from 12.4, and also please dig out the notes from 12.3 because we're going to use one of the pages in there and it'll be really helpful for you on the quiz and also on the final. You need the computer with a video, homework 48, and then your theorem sheet and vocabulary sheet for chapter 12. Okay, those are on the back wall of the classroom in the yellow folders. So please go get one, okay? Because you're definitely going to want them for the quizzes and the final. Okay, in sections 12.2 and 12.3, we learned how to find the surface area. We learned how to find the surface area of four solids: prisms, okay, cylinders, pyramids, and cones. Okay, and the homework involved finding the surface area of those four shapes. In these two sections, 12.4 and 12.5, we will learn how to find the volume of the very same four solids. So for each of these four solids, you're going to have two equations. You're going to have one for the surface area, and you're going to have one for the volume. So you want to make sure that's eight formulas in all, and you want to make sure that you're familiar with them. Obviously, you don't have to memorize them because you will be able to use your notes on the quiz and the final, but please be familiar with them. They're not hard, but they're not super easy either. Okay, I want to go past this for a second. Okay, so surface area. So we talked about surface area being like wrapping a present, okay, wrapping a box with paper, except that unlike when you normally wrap a present, you have like overlapping sides and sometimes you have some extra paper. With surface area, that's not what we want. We have to envision wrapping paper that fits exactly on each of the sides of the box or whatever figure it is, okay? So the surface area has to do with the outside of the box. How do I cover this side? How do I cover this side? How do I cover this side? Okay, volume is different. So volume is what goes inside the shape. Okay, like you're pouring milk into a beaker glass, okay? How much milk can go into that beaker or that glass? How much milk can go in? And that's what the volume is. Is it 3 liters, 4 liters, a gallon, 10 gallons, whatever, okay? And so what volume does is it takes a shape and it figures out how much room is inside the shape. Okay, surface area just looks at the outside, okay? The walls of the box or whatever figure it happens to be. The volume is what goes on inside. Okay, it's kind of like when you have a circle and we talk about the perimeter, which is the boundary outside, and then we talk about the area, which is what's inside. So this is very similar, it's just in 3 dimensions. So you have a 3-dimensional box or figure, and then you have a 3-dimensional figure, but you have this outside of the 3-dimensional figure and the inside of the 3-dimensional figure. So make sure you have those two things really, really solid in your mind, okay? And also that means that you need to read the questions in the tests or the quizzes very carefully. Are they looking for a volume or are they looking for a surface area? And then you go find the appropriate formula. Okay, so in this section we're going to look at the volume of a prism and a volume of the cylinder. Okay, these two items. So remember, a prism is made up of two bases, and the bases are opposite each other. Okay, and they're also congruent, and that's how we know that they're bases. And we also know that bases come in many different shapes. They can be rectangles like these here. They can be triangles, hexagons, pentagons, octagons, whatever, okay? And the volume is very simple. It's just the area of the base, okay? So this yellow part right here, the area of the base times the height, which is right there. So the first thing that you'll figure out when you're going to do a volume problem, similar to surface area problem, is what is your base. You're going to find the area of that base, and then you're going to multiply it by the height, and you're done. Okay, volume of a cylinder is similar. Okay, remember these have straight sides, straight vertical sides, not like a pyramid. Okay, the volume of a cylinder is also base times height. But because it's a cylinder, this base is a circle. And we know that the area of a circle is pi r squared. And so we have the area of the base, which is pi r squared, times h, and that's going to be the volume of a cylinder. Okay. Okay, so I'm going to pop back up. Okay, this is the page that was... Okay, here we go. Okay, this is the page that was in your 11.3 notes, and this is a very handy page, and you should make sure you have it with you whenever you do your homework, take quizzes, or definitely when you take the final. Okay, so here you have your surface area calculations. Here you have your prism. Here you have your cylinder. Okay, and we're just going to add the volume so that it's on the same sheet of paper and you don't have to go looking all over the place. So volume is the base, the area of the base, times the height. And with a cylinder, the volume is the base times the height, which, because the base is a circle, it's going to be pi r squared h. So actually, taking the volume is easier than doing the surface area. And then in the next video, we're going to look at this the volume of these two shapes down here. So please, on that one piece of paper that you got in 11.3, please put both the surface area and the volume formulas, and then you don't have to go digging through a bunch of papers to figure them out. Okay. Okay, so here's a couple problems. So here we're looking for volumes, not surface area. And remember, our formula for the volume is the area of the base times the height. So here, number A, or letter A, which are our bases. So remember, our bases have to be opposite each other and they have to be congruent. So obviously this side and this side and this side, those are not opposite each other. So those would not make good bases. So here's our one base, and then the other base is down here. So they are congruent and they are opposite each other. So we're going to try to find the area of the base. Okay? So first thing to ask is, what shape is the base? So this shape here is a trapezoid. And if you go to your formulas, the area of a trapezoid is equal to 1/2 times the height times the addition of the two bases. Okay, so the area of the bases, here's our 1/2. Okay, here's the height. That's interesting. I would say the height was equal to 5. Oh, sorry. Okay, my bad. It's the height of the trapezoid. Duh. Okay, so that's 3. Okay, here's the height of the trapezoid, and here's the length of the two bases. This one's 6, and this one's 14. Okay, so you calculate all that out, and you come out with 30. Okay, 30. You plug that into your volume equation, and base times height, the area of your base is 30. Our height here is 5, and so our volume is 150 centimeters squared. Okay, pretty easy. Sorry for my brain malfunction there. Okay, right cylinder, just as easy. V equals BH equals pi r squared h. Okay, our r is equal to 9, and our base, our height is equal to 6. So V equals pi r squared h, V equals pi times r, which is 9 squared, times the height is 6. Okay, long story short, it comes out to 81 pi feet squared. We're going to use the height of 6. Okay, 81 pi times the height is 486 pi, and you plug in 3.14 for pi, and that's what you get for your volume. Okay, pretty easy, yeah? So now, if you take a look at the homework, what I said in the homework was that you were to do all of the problems in those groups. There's 2 groups, prisms and cylinders. And I'm going to do a couple of the problems in each group, and you need to do the other ones. So I picked the harder ones, so you should be able to get through the easier ones pretty easily. Okay, so let's look at this one. This is number 9. I believe you have to do 7, 8, 10, 11. I'm going to do 9 and 12. But you can find these on your homework. So how do we do this? Okay, so first we decide what's our base. And clearly this is one of our bases, and then the other one is back here. Again, they're opposite from each other and they're congruent. Okay, and what is the height? Okay, I'll erase that back one. Okay, so imagine if you set the base on a table. Okay, so it was long ways up. Okay, and then here's my pentagon going back. Okay, and then I'm going to go up. I'm not really good at drawing this on the computer. Okay, definitely not good at this at drawing on a computer. So here's the rest of our polygon, but basically the idea is that this side, this 1, 2, 3, 4, 5, 6 hexagon is on the one that's on the table. Okay, so our base has 6 sides, 1, 2, 3, 4, 5, 6. So this is a hexagon. Base is a hexagon. Okay, and we need to find our volume, which is V times the area of the base times the height. So this means we're going to have to find the area of the hexagon. And you guys have done this before, but this problem, okay, we know that all these edges are 7.5. And we know that to find the area of this hexagon, we're going to need to use the formula 1/2 the perimeter times the apothem, or the apothem times the perimeter, either way. Now you notice that this doesn't have an apothem. They don't give you an apothem. So in this case, you would need to figure out this problem, you would need trigonometry to do that. And I am not going to give you this kind of problem with trigonometry on the final, okay, or the quiz. So I'm going to give you the apothem, and I'm going to say it's 6.5. So A is equal, apothem is equal to 6.5. And I would do the same for you on the test. Or I would give you this hypotenuse of this little triangle or this leg of the triangle, and then you'd have to use the Pythagorean theorem to figure out the apothem, okay? But in this case, I'm just going to give you the apothem, okay? So this is going to be 1/2, okay? My apothem is 6.5, and now we have to figure out our perimeter. So our perimeter has 6 sides. And we know each of those little sides is 7.5 centimeters. Okay. So there's our setup equation. So 6.5 is the apothem, 6 is the number of sides, 7.5 is the length of each of the sides. Okay. Oh, you know what I did in my calculations? I used the 18 as the length of the sides. Okay, so let's do that. Sorry, got to erase. Okay. So I'm going to use height equals 7.5 centimeters, and the sides are equal to 18. Okay, so all we got to do is, sorry guys. Trying to do this in a hurry so I can get it out to you tonight. Okay, so hopefully that won't make too much of a bust on your paper. Okay, so long story short, this turns into B equals 1/2 AP, AP. Okay, P is equal to 108. Okay, so it's 1/2. 6.5 times 108. Okay. And long story short, the base is equal to 350.73. Okay, so that gave us our base. So our volume is going to be equal to 350.73 times our height, which is 7.5. Okay, and that equals roughly what's here in the pink of 2,630 point something. Okay, they used 56. I think this comes out to be a little bit different, but it's not that big a deal. Okay, so the volume of this pyramid, okay, is 2,630 in some odd centimeters cubed. Okay. So again, you've got to find the area of the base. In this case, it was kind of difficult because it was a hexagon. Okay, other problems may or may not use a hexagon as a base. They might use something else. For example, this guy. So here we have a cylinder. Here we have a cylinder. Okay, so our volume is going to be equal to pi r squared h, and this is very much just a plug and play. So here's our h, is 9.8. Okay, our diameter, okay, all the way across here is 26.8, but our formula calls for the radius, not the diameter. So what do we need to do? We need to divide the diameter by 2. And so we're going to go 26.8 divided by 2 is 13.4, and that's going to be equal to r. So that line here is going to be 13.4. So now we're ready to play. So V equals pi. Our r is 13.4 squared. Our h is 9.8. Okay, and so we have that, and that is equal to basically what it says down here. Okay, I think I got 25.42 because I just used 3.14 for for pi, and these two are close enough. Okay, you would not get an error for that. So you see a cylinder, it gives you the diameter or the radius, and it gives you the height. You're in Fat City. You can easily figure out the volume. Okay, so this guy looks a little bit more daunting, even though he's really not. But this is on the second page, or the second set of problems. So here, again, remember what we've done before in the past with surface area is you have a bigger figure. Okay, in this case, it's a fairly large cube. And then inside, there's a smaller figure. Okay, and they want you to find the difference. Okay, so they want you to find the volume that is inside the bigger box, but does not include this box here. So we want him to go away. Okay, so now we can find the volume of both the big box and the little box. We subtract them, and then we have the part that's left over. And that's our general approach. So the volume of the cube, okay, so the volume of the cube is equal to the base, well, let's see here. Okay, V cube, volume equals base, right? Base times height. Okay, let's use this down here as our base. So the base is going to be, the area of the base is 12.4 times 7.8. And multiply that, and then we're going to multiply that by the height is equal to 9 feet. Okay. So long story short with that is it's equal to 870.48. Okay. So the volume of that little middle box, again, is equal to base times height. And they give you this information of, so we're looking for this area. This is one of the bases. Okay, and we're told that this side is 1.8, this side is 3 feet. So our base is 1.8 times 3, and our height is still 9. So we calculate all that out, and we get 48.6. So now we can't forget the last part, which is to subtract. Okay, you start out with a large cube, you subtract the little one, and you get what's left over. Okay, equals 870.48 minus 48.6, and that is equal roughly to 821.88. Okay, just like it says in pink. So it's very similar to what you've been doing. The basic idea is the same. You're just using a little bit different formulas for the volume in this case. Okay, that's it for this video, and we'll see you on the next one.